A box of mass M is suspended from the ceiling by two ropes at different angles, θ1 and θ2, with respect to the vertical. So that's where the angles are. Draw a free body diagram for the box. Do not draw components of the forces on the diagram. Derive an expression for the forces acting in the x and y direction in terms of the mass, the tension force in each rope, θ1 and θ2. Then, which tension force is greater? Justify your answer. Well, we've got gravity pulling down on the mass, and then we have T2, the tension force, in the direction of that rope, and T1 in the direction of that rope. Derive an expression for the forces. So we have our T2, we have our free body diagram, and what we've done is we've overlaid an XY coordinate system. The mass is right over here, and we need to resolve the tension forces into X and Y components. The box is not moving, so the acceleration and the net force in both directions is 0. So let's look at the X direction first. We're going to take positive to the right, pretty standard, and then when we do the vertical, we'll take positive up. But let's stay with horizontal. The sum of the forces in the X direction is T2 cosine θ2. Right, here's theta. Here's the hypotenuse, so the adjacent side is cosine theta. And you've got T1 cosine θ1 to the left, and the sum of the forces there is 0 because it's not moving. Now let's do the vertical direction. We have both of them are in the up direction, both tensions, T2 sine θ2 and T1 sine θ1. Here they are. And we have one force going down, which is mg, so that's negative. And once again, the acceleration is 0. Which tension force is greater? Justify your answer. We're going to work with the sum of the forces in the x direction. Why? Because it's simpler. We don't have mg there. And whatever we find for a relationship between T2 and T1 here would be the exact same in the y direction, right? Because T2 is going to be the same. Either equation will give you the answer. So we have T2 cosine theta equals T1 cosine θ1. We just added that guy to the right side. Divide both sides by cosine θ2. So now we're in a position to analyze this. We look at the picture and we see that θ1 is greater than θ2. So because that's the case, the cosine of θ1 will be less than cosine θ2, right? The bigger the angle gets, the smaller the cosine function gives you. And what does that tell us? Well, let's look at our box here. If cosine θ1 is less than cosine θ2, this number here will be less than 1. So let's just pick a number less than 1. T2, we don't have to be exact here. What's less than 1? Let's say a half. So this tells us that T2 is less than T1, right? Because it's half of what T1 is in this example. You could put any fraction there, 1/3, 1/100th, whatever you want to do. So if T2 is less than T1, T1 is greater than T2. In words, the more vertical the rope, the greater the tension. So if you've got two ropes like that and you're trying to pick up a box with somebody and the other person's stronger than you, make that person hold the line more vertical than you are. That person will be bearing more of the load.